Okay, for 7.3 for sample means, I have an example here for movie-going students. Suppose the number of movies viewed in the last year by high school students has an average of 19.3 with a standard deviation of 15.8. Suppose we take a simple random sample of 100 high school students and calculate the mean number of movies viewed by the members of the sample. What's the mean of the sampling distribution of X bar, which is the sample mean? And the sample mean is going to be the same thing as the mean. So if the mean of this problem is 19.3, then the mean of sampling distribution is going to be 19.3 if the population's mean is 19.3. What's the standard deviation of the sampling distribution of X bar? Check whether the 10% condition is satisfied. So for a minute, let's take a minute for the 10% condition. You are sampling 100 high school students. Are there more than, we want to make sure that that's 10% or less. Overall, how many people do you think are high school students? And for this one, I think we could be talking about the United States. So there should be a ton. And 100 is definitely smaller than 10%. So there's no real math to show for something like that besides for 10 times as much is 1,000. So do we think we have more than 1,000 high school students total? Yes. The standard deviation, now you have the standard deviation up here. And this is of all high school students. So to find the standard deviation of the high school students within the sample, you have to add in something about the number of students you're surveying, because your standard deviation is going to change the more and more people that you are surveying in there. Remember, we talked about the bigger the sample, the less variability. So you're going to have a smaller spread. So when you do this is the formula. The standard deviation of the sample is the standard deviation of the population divided by the square root of n. So how that works is, from the example, we've got 15.8. And we're doing 100 high school students. So we have to take into account that we're asking 100 people. And we square root it and we get 15.8 divided by 10. So it looks like our standard deviation is 1.58 now. And this is right from your formula sheet. And this is what it looks like. If X bar is the mean of a random sample of size n from an infinite population with mean mu and standard deviation sigma, then the mean of X bar equals the mean, and the theta of X bar equals theta divided by the square root of n. So exactly what we were just working with. One thing to add in is, if the population distribution is normal, then so is the sampling distribution. Of X bar, no matter what size the sample it is.